Assalamualaikum everyone. My name is Khairul Nukman bin Zainal Abidin and I am going to present my project research of supply chain logistics optimization, which is supervised by Dr. Azlin binti Ahmad. So let's start with the introduction. So what is supply chain? Supply chain is the concept of delivering value to clients in a step-by-step kind of manner. So now the concept of supply chain can be correlated with the background of study, whereas the term value can be equated to the products or goods that will be delivered, and also the step-by-step manner is the process of how the product is managed. First, it originates from the origin port, then stored in the warehouse and will be delivered to the destination port via a transportation. So the problem of this project research is based on the supply chain logistics problem dataset from Brunel University London. It is made by Tatiana Kalganova, and the elements resides in the dataset is that each warehouse has its own daily limit, and each product is meant for specific customers, and most importantly, it caters around 15,000 possible routes. So it is quite concerning because there are lots of resources that needs to be handled, and there might be a possibility of inefficiency in handling the supply chain resources. So inefficiently handling the resources can bring in the impact of high supply chain logistics total cost, and we definitely don't want that to happen. So what should be done? So let's start with an assumption like maybe we can ideate to reduce the cost using an optimization method, in which brings up a question of how can an optimization model attain cost-effective supply chain logistics? And assuming that if we attain an optimized supply chain logistics, what are the routes that are preferred for the cost-effective supply chain logistics? So based on the research questions, now we can construct the objectives of to produce cost-effective supply chain logistics using an optimization method, and also to analyze the specifications of routes of cost-effective supply chain logistics through a dashboard visualization. So the scope is as mentioned in the problem statement. It revolves around the SCLP dataset, and the dataset has four distinctive tables, which are the order list, freight rate, warehouse cost, and also the warehouse capacity. And also for the optimization, it uses parallel and colony optimization, and it will be equipped by a cost-effective objective function. So this project research has its benefits, which is able to attain cost effectiveness to minimize cost, and the time of search for optimal logistics routes can be reduced. And also the optimized results can be analyzed for further analysis and also insights. So that is for chapter 1. So let's hop into chapter 2, which is the literature review. So the literature review that have been made for this project research is approximately around 30 research papers, and the literature review is quite simple actually. Like the domain is focused on the supply chain, and as for the technique, it is focused on the optimization. And also there's a mix of both, so that can be well integrated between the two domains and also technique. Like for example, for the supply chain, it focuses on the history and evolution of supply chain, managing the sustainability of supply chain, logistics and supply chain management, and also Industry 4.0 on supply chain. As for the optimization, it focuses on the end colony optimization, genetic algorithm, and also fuzzy logic. And for the mix of both, it focuses on the end colony optimization on supply chain, genetic algorithm on supply chain, and also fuzzy logic on supply chain. So that's practically it for the second chapter. So let's proceed on the research methodology. Okay, so here we have the research methodology phase. So we start off with the preliminary study, followed by the knowledge acquisition, data acquisition, and also the data preparation. And the phases that covers the first objective of the optimization are on the system design, model development, and also the model testing and evaluation. And the last phase, which covers the second objective, is the visualization. So here we have the end colony optimization pseudocode. So it will run all ends in parallel, and each iteration will have its pheromones compared so that the ends can converge towards the best end. Then the best end will affect in the next iterations and deployment exploration, as the ends will now follow the pheromone deposits. So the objective function will calculate its goal based on the minimum summation of warehouse costs and transportation costs. So for the second equation, the warehouse costs are obtainable based on the quantity of items that needs to be stored and the rate of each item. So the transportation cost is calculated in a complex manner actually. Like if the service level is CRF, then the transportation cost will automatically be zero. When the transportation method is via ground, then a specific formulation has been derived, which is that the transportation cost is proportional to the weight consumed by the order in respect of the total weight of route and the rate charged by the courier. In all other scenarios, the transportation cost will have the default formula based on the order weight and also the freight rate. So with that being said, let's keep on going to chapter 4, which is on the experimentation. So in this chapter, we are going to do parameter tweaking by the values of iterations, ends, and also alpha and beta. So here we have the list of all parameters and the description of what will be affected during the experimentation. So the iteration will be tweaked in the range of 10 to 30. As for the ends, will be tweaked to 5 to 20, alpha 0.5 to 2, and also for beta 1 till 6. So these are the sample graphs that will be obtained from each and every experimentation. So we have the standard deviation list in a float representation, and the second one is also the standard deviation but based on a line graph. Then we have the cost reduction line graph. So these are the results for the iteration parameters, and these are for the ends deployment parameters, the alpha value parameter, and also for the beta value parameter. And from the 9 experimentations that have been done, we have now obtained the optimal value for each parameter for the final experimentation. Like the number of iterations will be lowered from 20 to 15 as the ends usually converge in 15 iterations on average. And it also saves time. Then we will increase the number of ends deployed from 10 to 20 as higher number of ends will help in faster solution convergence. So for the alpha value, we will increase it to 2 as a higher value of alpha brings forth better optimization value. And lastly, for the beta value, it will still remain to its default value because higher value produces a less optimization value. So it is best to keep it to a minimum. From this list of standard deviation, it is observable that the model converges to the 12th iteration, and we can see a downward trend on the line graph. So for the results of the final experimentation, it is observable that the total cost has been reduced from 8.4 million to 7.8 million. And that's a reduction of $500,000. Like that's a lot. And in this case, it optimizes to up to 6.54% of the initial cost. And also, after obtaining the optimized supply chain logistics, the data will then be turned into a dashboard such as this one. And well, yeah, I'll be touching a few for storytelling. Like the first one would be this pie chart for count of pod by plant code. So the pie chart shows that the optimized logistics stems from 3 distinct plantations, and it is observable that plant 03 is the most preferred alternative to go through as it dominates around 71.25% of the whole optimized supply chain logistics, whereas plant 12 holds the smallest fraction of logistics count. So the second one would be the tree map for count of plant code for pod. So it shows that the count of plant code filtered by pod, and as we can see that the tree map illustrates that most of the supply chain logistics originates from pod 04. And the second one is actually a much more specific breakdown of what has been represented. But the difference is that it scales with cost. Although port 04 brings in a lot of costs, it is actually preferred in the supply chain logistics because it can be assumed that port 09, like for instance, port 09 has alternative routes that are way more expensive. And upon a thorough experimentation with different parameters tweaking of iterations as alpha and beta, optimal parameter value has been achieved. And the usage of optimal parameters has shown results of the best optimization improvement compared to all other parameter tweaking. And it shows that even though the algorithm of end colony optimization initially plays a major role in reducing the total cost of supply chain logistics, but the parameters still plays a huge role in ensuring that the optimization can be maximized in order to make better decisions and insights. Okay, so for this segment of presentation, I am going to briefly explain on how the end colony optimization model works. So this is the overall structure. It has the libraries, parameters, dataset, data preprocessing, main function, and also the other functions. So for the libraries, multiprocessing, pandas, and also random has been used. And as for the parameters, it has been mentioned previously that it contains four parameters, which are the numbers of iteration, number of ends, and also the alpha value and beta value. So for the dataset, it originates from the SLP dataset and will be imported to its designated data frame for each table. And as for the data preprocessing, yes, it might seem a bit complex with all the aggregations, but to simplify it, in the end, the supply chain logistics network will look like this. Yes, like this. And so let's head on to the main function. This is where the parallel ends will be deployed. So the concept of parallel end is actually being executed by using multiprocessing, in which all ends will be deployed simultaneously. So for the ACO traversal function, this is where all the selections will be done. Like for this segment, it is to select the order ID. And the next one is to select the carrier. And also the next one, after getting the route will have its cost calculated, and then the availability of the routes will be updated. So for the selection, first it will eliminate routes that have already been traversed. Then the selection will be done via a roulette wheel method. So for the objective function, the route with the lowest cost will have the highest fitness value. And this is the logic for the transportation cost. And this is for the warehouse cost and capacity. So if the warehouse is full, then it will prompt that the warehouse is full. So the final function is on the pheromone update. The fitness value that we have obtained in the objective function will be translated into pheromone, which will be used for the next iterations. And yeah, that is overall it for the structure of ECO model. And that is all from me. Thank you for watching.